A while ago, I was at my friend's house and we were eating popcorn. After dropping a piece of popcorn on the floor, she just picked it up and said 5-second rule and then ate it anyway. This led me to wonder, does dropping food on the floor for different periods of time change the amount of bacteria that grows in the food? Does dropping food on the floor for short periods of time prevent bacteria from contaminating the food? My hypothesis was that if I dropped food on the floor for different lengths of time, then the food left on the ground for longer would grow more bacteria. The first step in my procedure was to build the incubator. Since I did not have access to a commercial incubator, I had to build one myself. I used a foam cooler, and I duct taped a picture frame to the front, and I used a 25-watt light bulb to power the incubator. I put a temperature and humidity sensor inside the incubator to make sure that the temperature was around 98.6 degrees, and I had to cut holes all around the incubator because it kept getting too high, and it took me 3 days to get the incubator to the right temperature. The next step was to prepare the petri dishes. First, I cleaned the counter with 70% isopropyl alcohol, and then I lined up all my petri dishes, and I had 20, and then I microwaved agar in the microwave until it was liquefied, and then I poured it into all my petri dishes and waited an hour for it to solidify. I chose to drop bologna because it's sticky and it's like rough. It has a rough surface, so it would probably collect a lot of bacteria. And I had 5 groups. The first group was the control, and I had one of those, and it was not enough. The next group was the undropped group, which basically I just swabbed it with bologna that had not been dropped. And the next group was swabbed with bologna that had been dropped for 5 seconds, and I had 6 of those. And I had another group of 6 that was swabbed with bologna dropped for 20 seconds, and another group of 6 swabbed with bologna dropped for 50 seconds. The next step was to drop the bologna. I marked out a 3 by 3 foot area of linoleum floor, and I did not clean it, but I made sure it was not visibly dirty because I wanted it to reflect what an average kitchen floor would be like. And I took a half piece of bologna and I dropped it on the floor for 5 seconds, and then I picked it up and swabbed it with a cotton swab, and I inoculated the petri dish, rotating it 45 degrees in between inoculations so that I would reach all 4 quadrants of the dish. And I did this 6 times for 5 seconds, 6 times for 20 seconds, and 6 times for 50 seconds. And then I put all my petri dishes in the incubator for 5 days, and I took pictures of them each day. The next step was using ImageJ to count the colonies. ImageJ is a software that you can download that counts the number of colonies on a surface. So first, you open ImageJ, and then you open your picture, and then use the Analyze Particles feature to count the number of particles on the dish. Then you use ImageJ to count the number of particles on the dish. And I wrote it down on an Excel spreadsheet. And besides the materials I already listed, I had a few other materials that I used. And I did not have much risk and safety, except that I had to put the petri dishes upside down in the incubator so that condensation did not drip onto them. And I wore gloves and a disposable mask so that I did not contaminate the dishes. And I also wore oven mitts when handling the hot agar bottle. My data analysis method was to take pictures of the petri dishes each day for 5 days and use ImageJ to count the number of colonies on the dish. And I used multiple graphs to show the number of colonies on each dish. I graphed the number of colonies on each dish per day, the average number of colonies in each group per day, and the average number of colonies in each group over all days. The first graph shows the number of colonies counted per day. I use a different color to represent each day. And on the x-axis is the sample, and on the y-axis is the number of colonies. Most of the 5-second group was about the same, except there were a few outliers. Same with the 20-second group, although 20 number 6 was an outlier. And in the 50-second group, 50 number 1 was an outlier. The next graph shows the average number of colonies per group each day. I used a different color to represent each day, and on the x-axis is the sample group, and on the y-axis is the average number of colonies. It seems like the 20-second group was lower than the others, but then my next group, which shows the average number of colonies in all the groups over all the days, showed that the 20-second group was only slightly lower than the others. The 50-second group was a lot higher, but this was because the outlier 50 number 1, which raised the average. These graphs led me to form some conclusions. The number of colonies in the undropped group is similar to the number of colonies dropped for various times, which means that the 5-second rule does not apply. Another explanation for this is an experimental error. I should have done more undropped dishes, but I ran out of agar and I did not have enough for 6 undropped dishes. Results showed the longer times dropped did not exactly result in more growth. This disproves my hypothesis, which was that if I dropped food on the floor, then the food left on the ground for longer would grow more bacteria. There were some outliers, such as 20 number 6 and 50 number 1. As I previously said, 50 number 1 raised the 50-second average. Image data is an objective way to count colonies, but there are some errors based on where the colonies are located and their shape and size. Image data counts a colony that is round, of a certain size, and not connected to any other particles. An interesting experiment would be to test other types of lunch meat or other types of food to see if it produced the same or similar results. Maybe I would try a more moist food or a more dry food to see if it produced more or less bacteria. I learned a lot about bacteria and how to plate bacteria and the conditions for bacterial growth. And this matters to people who believe in the 5-second rule, like my friend, because it does not matter whether food was dropped on the floor for 5 seconds or 50 seconds, because it collects a similar amount of bacteria. I would like to thank my parents and my teacher for helping me with my experiment. Thank you.